You think you know this insect. You've swatted it away from your soda can. You've flinched when it landed on your arm at a summer barbecue. You've probably called it useless, aggressive, pointless, an insect that exists purely to ruin your afternoon. But everything you've been taught to feel about this creature is built on a misunderstanding so complete that scientists who study it for a living get frustrated every single time they hear you talk about it. Because the insect you've spent your whole life trying to avoid isn't a nuisance. It's not a lesser cousin of the bee riding on borrowed reputation. It is one of the oldest, most successful predators on the entire planet. A creature that was already ancient when the first flowering plants appeared, that watched entire epochs of Earth's history collapse around it and simply kept going. It is not nature's mistake. It is nature's most underrated survivor, and the story of how it has outlasted almost everything else alive today reads less like an insect documentary and more like a masterclass in evolutionary endurance. Let's move fast, because the raw numbers alone will change how you see every single one you swat away this summer. Wasps have existed on Earth in some form for roughly 200 million years, predating not just humans, but most of the animals we consider ancient. They are the evolutionary ancestors of both bees and ants, meaning every honeybee in every hive on the planet is, in a very real sense, a descendant of a wasp that adapted a different lifestyle. A single wasp colony can capture and provision its nest with thousands of caterpillars, flies, and other pest insects across a single growing season. Some wasp species can recognize individual faces among their own colony members, a level of social cognition once thought impossible in an insect with a brain smaller than a grain of rice. Wasps survived the asteroid impact that ended the age of dinosaurs, a mass extinction event that wiped out roughly 3/4 of all species on Earth. There are more than 30,000 identified wasp species worldwide, ranging from parasitic wasps smaller than the width of a human hair to solitary hunters capable of paralyzing prey many times their own size. And in a quiet, unglamorous way, wasps are disappearing from gardens and farmland across large parts of the world right now, at a moment when we understand their ecological value better than we ever have before. None of that sounds like the resume of an insect most people would happily eliminate on sight. So let's actually go back to where this story starts, because to understand what a wasp really is, you have to understand just how long it's been quietly running the show. Start with time, because nothing about the wasp makes sense until you understand exactly how old this lineage really is. The oldest wasp fossils discovered date back roughly 200 million years, placing the origin of this insect group deep in the Triassic and early Jurassic periods, long before most of the animal groups we consider primeval had even appeared. For context, this means wasps were already established, diversifying and hunting other insects, while the very first dinosaurs were still evolving into the giants we picture today. When the asteroid struck roughly 66 million years ago and ended the reign of the dinosaurs, wiping out an estimated 3/4 of all plant and animal species on the planet in a geological instant, wasps were among the survivors. Their small size, underground and cavity nesting habits, and flexible diet likely helped shield entire lineages from the worst of the immediate devastation, allowing them to persist while far larger, more specialized animals vanished entirely. Every subsequent ice age, every major climate shift, every dramatic reshaping of the continents happened with wasps already present, adapting in the background the entire time. By the time modern humans evolved, wasps had already been running. The same basic evolutionary playbook, hunting and provisioning and building nests, for longer than most currently existing mammal families have existed at all. That depth of history is worth sitting with because it means the insect landing on your picnic table today carries a lineage older than almost anything else you'll see outside that afternoon, and that ancient body plan, refined over 200 million years, is exactly where the real engineering begins. Because underneath that simple black and yellow exterior is a body built with a level of precision that puts most predatory insects to shame. A wasp's exoskeleton is a rigid segmented shell made of chitin, a tough structural material that provides both protection and a lightweight frame for rapid, efficient flight, allowing many wasp species to fly with a speed and maneuverability that rivals far larger predatory insects. Their compound eyes are made up of thousands of individual visual units, giving them a wide field of view and exceptional sensitivity to motion, which is precisely why a wasp seems to notice you moving before you've even registered that it's there. Their mandibles are strong enough to shred tough insect exoskeletons, chew wood fiber into pulp for nest construction, and manipulate prey with a level of dexterity that looks almost mechanical when slowed down. And then there's the stinger, the single feature responsible for almost all of the fear surrounding this insect, which in most wasp species is actually a modified egg-laying organ called an ovipositor, meaning only female wasps can sting at all. And in many species, that stinger evolved first and primarily as a tool for paralyzing prey rather than a defensive weapon against humans. Unlike a honeybee, most wasps can sting repeatedly without dying in the process, because their stinger lacks the barbed structure that traps a bee's stinger in skin. That single anatomical difference is responsible for an enormous amount of the fear and mythology surrounding wasps, even though, biologically speaking, it exists for reasons that have almost nothing to do with humans at all. And once you understand what that stinger was actually built for, the wasp's real role in the natural world starts to look completely different. Because at its evolutionary core, the wasp is a hunter, and its hunting behavior is some of the most sophisticated predation you'll find anywhere in the insect world. Many solitary wasp species specialize in hunting a single type of prey with remarkable precision, using scent, vibration, and visual cues to locate caterpillars, spiders, or other insects with an accuracy that borders on surgical. Once prey is located, many wasps deliver a precisely targeted sting that doesn't kill the victim outright, but instead paralyzes it, keeping the prey alive but immobile so it can be transported back to a nest and used as fresh food for developing larvae. A strategy so effective that it has remained essentially unchanged for tens of millions of years. Some parasitic wasp species take this even further, laying eggs directly inside a living host insect, allowing their larvae to develop from the inside out in a process so precise and so biologically ruthless that entire branches of pest control. Research have been built around deliberately introducing these wasps into farmland to control crop-damaging insects naturally. Social wasp species, the kind most people are familiar with from backyard nests, take a more communal hunting approach, with worker wasps foraging across a wide radius and returning again and again to feed a shared brood, meaning a single, healthy nest can systematically clear caterpillars, aphids, and other pest insects from a garden or farm field far more efficiently than most manual pest control ever could. That single fact alone quietly reframes the wasp's entire relationship with human agriculture, because an insect most people try to eliminate on sight is, in a huge number of documented cases, actively protecting the crops and gardens people depend on. And that hunting efficiency becomes even more remarkable once you look at how these colonies are actually organized. Because wasp social structure is far more complex and far more organized than most people ever give it credit for. In social wasp species, a single queen typically emerges from hibernation in spring and begins building a small paper nest entirely. Alone, chewing wood fiber mixed with saliva into a pulp that hardens into the papery layered material a wasp nest is famous for. That queen lays the first generation of eggs and initially forages and defends the nest single-handedly, meaning the entire colony's survival rests on one individual insect during its most vulnerable early weeks. Once the first workers hatch, the colony's labor divides rapidly, with workers taking over foraging, nest construction, and larval care, allowing the queen to focus almost entirely on reproduction for the remainder of the season. Communication within the colony relies heavily on chemical signals called pheromones, along with tactile cues like antennae contact, allowing a colony that may eventually include hundreds or even thousands of individuals to coordinate nest defense, foraging routes, and brood care without any centralized command beyond the queen's reproductive role. Some research on paper wasps has even demonstrated a level of individual facial recognition among colony members, with certain species able to distinguish between the facial markings of different individual wasps, a level of social cognition that researchers didn't expect to find in an insect with such a comparatively small brain. By late summer, most social wasp colonies begin producing new queens and males specifically for reproduction, who leave the nest to mate before the original colony, including the founding queen, dies off entirely as the weather turns cold, with only the newly mated queen surviving through winter to start the entire cycle over again the following spring. That single-season, queen-driven life cycle is strikingly different from the multi-year colonies many people assume all social insects maintain, and it's part of what makes the wasp's survival strategy so specifically built for resilience rather than permanence. And understanding that fragile, restart-every-year colony structure makes what's currently happening to wasp populations even harder to ignore. Because right now, in gardens, farms, and green spaces across large parts of the world, wasp populations are quietly declining, and the reasons behind that decline are worth taking seriously rather than dismissing with relief. Widespread use of broad-spectrum insecticides in agriculture and residential gardening doesn't just target pest insects, it also kills the wasps that would otherwise be preying on those same pests naturally, disrupting a pest control system that had been running effectively on its own for millions of years. Habitat loss plays a significant role as well, with the disappearance of hedgerows, wildflower meadows, and untreated wild spaces removing both the nesting sites and the diverse insect prey populations that healthy wasp colonies depend on throughout the season. Shifting climate patterns are adding further pressure, with unpredictable spring temperatures affecting the survival odds of queens emerging from hibernation, a single, vulnerable point in the wasp life cycle where an unusually early or late cold snap can wipe out a disproportionate share of an entire year's founding queens before a single nest is even built. And unlike bees, which have benefited from a wave of public conservation attention over the past decade, wasps have received comparatively little protection or research funding, largely because public perception still treats them as pests worth eliminating rather than as the pest-controlling predators and, in many species, pollinators that they actually are. That gap between public perception and ecological reality is, in many ways, the central tragedy of the modern wasp's story, because the insect quietly doing an enormous amount of unpaid pest control in the background is disappearing largely because almost nobody has ever been told they should care. And that gap in public understanding becomes even more striking once you look at how deeply wasps have actually been misjudged. Here is the misconception laid out plainly: the assumption that wasps are simply aggressive, useless, and purely destructive, existing only to sting and ruin outdoor meals, with none of the redeeming ecological value that has helped rehabilitate the bee's public image over the past several years. That reputation doesn't hold up well against the science. Beyond their role as natural pest controllers, many wasp species are also meaningful pollinators, visiting flowers for nectar and inadvertently transferring pollen in the process, including for certain plant species that have evolved to rely specifically on wasps rather than bees for pollination. Fig trees are perhaps the most striking example, with many fig species depending entirely on a specific tiny species of fig wasp for pollination, a relationship so precise and mutually dependent that neither the tree nor the wasp could reliably reproduce without the other. Wasps also serve as a significant food source for birds, spiders, and other predators throughout the food web, meaning their decline doesn't just remove a pest controller from an ecosystem, it removes a foundational link that other species depend on as well. The aggressive behavior most people associate with wasps is also largely limited to nest defense during a narrow window in late summer, when colonies are at their largest and most food-stressed, rather than representing the insect's default temperament for the rest of the year. In other words, the wasp most people picture as a purely hostile insect is, for the overwhelming majority of its life cycle, a quiet, highly efficient predator, an occasional pollinator that almost never seeks out confrontation with humans at all. And once you strip away that misconception, the deeper, more surprising truth about this insect's importance finally comes into full view. Because here is the fact this entire video has been building toward, the piece of evidence that makes the wasp's true value almost impossible to dismiss once you actually understand it. Researchers studying the pest control value of wasps in agricultural systems have found that social wasp colonies alone are estimated to remove a volume of insect pests from crops and gardens that would otherwise require a substantial increase in chemical pesticide use to control through artificial means, meaning a single healthy population of wasps functions as a free, self-sustaining pest control system worth a genuinely significant amount in avoided crop damage and pesticide costs. Every single year, that means the insect most people try to eliminate on site is quietly performing a service that, if it disappeared entirely, farmers and gardeners would have to replace using expensive, environmentally damaging chemical alternatives, and in many documented cases wouldn't be able to fully replicate at all. Some entomologists studying this dynamic have gone as far as suggesting that if public perception of wasps shifted even modestly toward how bees are now perceived, encouraging garden owners to tolerate rather than exterminate nests found in low-risk locations, the resulting boost in natural pest control could measurably reduce the need for chemical intervention in backyard gardens and small-scale farms across huge areas. Sit with what that actually means. An insect responsible for a documented, quantifiable share of the world's natural pest control, one of the oldest, continuously surviving predator lineages on the planet, having outlasted the asteroid that ended the age of dinosaurs, is disappearing in real time largely because of a public relations problem rather than any fundamental flaw in what it actually does for the world around it. So the next time a wasp lands near your drink at a summer gathering, understand what you're actually looking at. You are looking at the direct descendant of a lineage that has survived roughly 200 million years of changing continents, ice ages, and mass extinctions that erased the vast majority of life on Earth. You are looking at a hunter precise, enough to have shaped entire branches of modern pest control science, and in many species, a pollinator quietly supporting plants and food webs most people never think to connect back to it at all. And you are looking at a creature whose slow disappearance from gardens and farmland right now is a loss most people won't notice until long after it's already happened. That is the insect we decided, somewhere along the way, deserved nothing but a swat and a grimace. Reconsider it. The next time one drifts past you outdoors, know that it belongs to one of the oldest, most quietly essential lineages left on this planet, doing work most of us have never once stopped to thank it for. If this changed the way you see the insects in your own backyard, consider following along for more. There are far more of these overlooked lives closer to you than you realize.